Dear online attendees, can you hear and see the screen? The online participants, Tejasvi, Amit ji, Jayan ji. Okay, thank you, glad. If there is any glitch, please message on the chat. Good morning, everyone, respected dignitaries, esteemed speakers, and dear participants. A very warm welcome to all of you on the day 2 of the International Conference on Art, Science and Technology of Ferrocement Construction, jointly hosted by Ferrocement Society India and Dr. Bhanuben Nanavati College of Architecture, Pune. As we begin the day, I take the opportunity to thank our sponsors, Vascon Engineers, Ultratech, and Mr. Umesh Chavan for their generous support to make the conference a success. Yesterday, we witnessed insightful deliberations, thought-provoking discussions, and a celebration of ideas that showcase the potential of ferrocement in shaping sustainable and innovative construction practices. Today, promises to be equally enriching with keynote addresses by eminent thought leaders and practitioners, followed by paper presentations and live demonstration of ferrocement construction. Before we begin, let me briefly present the schedule of the morning session. We shall start with the keynote address by Dr. Anthony Neyman, Mr. Arjun Doshi, Mr. Architect Manish Banker. We will also learn from Mr. Ulhas Paranjpe from Jalvardhini Pratishthan. Each session will be followed by a short question and answer to allow meaningful interactions. Post that, we will be proceeding towards the breakout sessions in room number 404 and 406 for the technical paper presentations by the presenters. So, we start with welcoming Dr. Naman. It is my privilege to introduce our first keynote speaker, Dr. Anthony Naman, joining us online from Ann Arbor, Michigan, USA. Dr. Naman is Professor Emeritus at University of Michigan, Ann Arbor, USA. He holds an MS and PhD degrees from the Massachusetts Institute of Technology, Cambridge, USA. He has been involved in teaching and research for more than 5 decades. His research studies have led to more than 350 technical publications, including textbooks on pre-stressed concrete, fiber-reinforced concrete, and ferrocement. He is a fellow and honorary member of the American Concrete Institute, ACI, fellow of the American Society of Civil Engineers, ASCE, fellow of the Precast Pre-stressed Concrete Institute, PCI, and fellow, founding member and past president of the International Ferrocement Society, IFS. We'll take a look at the brief video that showcases Dr. Naman's work, and post that Dr. Naman will be talking.
Hello, greetings.
Wait.
Hello, greetings. Ladies and gentlemen, distinguished guests and colleagues, I am very pleased and honored.
Naman sir, give us a moment.
अनफ्रीज झाले पण ही स्क्रीन नाही दिसत त्याच्यात.
more than 50 years. And while we gather to celebrate together the advancement and collaborative efforts in the field of ferrocement, I would like first to thank my long-term colleagues in the field from India, Professor Divekar, Professor Paramasivan, and Mr. Levy, and greetings as well to the organizer, the Bnca College, and the Council of Architects of India for inviting me to say these few words. Also, I would like to greet you on behalf of Professor Nassif, who is now president of our small International Ferrocement Society. Professor Nassif asked me to convey just two relevant pieces of information to you. First, the proceedings of the last two symposia on ferrocement. Ferrocement 13, which took place in Lyon, France in June 2021, and Ferrocement 14, which took place in New Jersey in the US in June 2024. These two proceedings are being printed and will be soon available to the public. And second, the preparation for Ferrocement 15, which will take place in Milan, Italy in 2027, is underway. So please keep that in mind and mark your calendar. Hopefully there will be more information on the web of the Society in the coming months. In the next few minutes, I would like to address briefly the small history and whereabouts of the International Ferrocement Society, now based in the US. You will be surprised to learn how it really started. During the course of the Third International Symposium on Ferrocement, which took place in New Delhi, India, in December 1988, a number of delegates expressed the need to create an independent organization to provide constant direction, guidance, and authentication for work carried out on ferrocement. The name suggested then was International Society on Ferrocement. It was further proposed that the new society be set under the guidance of the then existing International Ferrocement Information Center, which was located at the Asian Institute of Technology in Bangkok, with Professor Ricardo Palma as president. At that time, the center was headed by Dr. Lilia Austria and Professor Palma, research on ferrocement. The idea to create a society was again discussed during the Fourth International Symposium on Ferrocement, which took place in Havana, Cuba, in October 1991. Some of us, including myself, doubted the need to create a new society, given that we already had an American Concrete Institute and RILEM committees on ferrocement. However, we were all in agreement that we were in a dire need for a design and construction code on ferrocement, and a new dedicated society will provide the fastest and most effective means to achieve that. decision to create the International Ferrocement Society, short IFS, was thus taken in 1991 with Professor Ricardo Palma as first president. IFS was then officially registered in 1993 as an entity within the Asian Institute of Technology in Bangkok, in Thailand. The first Ferrocement model code was then published by the society in January 2001. Now a sad story. IFS was housed at the AIT library in Bangkok and given 2 dedicated rooms to store a collection of documents comprising practically anything published on the subject worldwide, starting in the 1940s. They included unique boat building reports and structures from New Zealand, Canada, the UK, Southeast Asia, and numerous other self-help projects worldwide. However, by 2006, due to severe budget constraint, the AIT administration took back the space housing IFS. About 8 tons of hard copy document, journals, reports, theses, photos, digital file, and videos were then moved and stored in boxes or files in the basement of the structural concrete laboratory at AIT. IFS continued to operate, all but with limited reach. The Journal of Ferrocement and the International Ferrocement Information Center were discontinued, but with the help of dedicated members, the organization of a continuous series of international symposia on ferrocement, namely since then Ferrocement 8 to 14, was maintained. Unfortunately, a great flood hit Bangkok in 2011, lasting about 175 days from July 25, 2011 to January 16, 2022. The Great Flood was considered one of the most devastating in Thailand's history, resulting in immense damage region-wide. The entire collection of the IFS document was soaked in water for a long period of time and totally lost beyond recovery. This prompted the action taken by a group of dedicated IFS members to create, to any extent possible, a repository of documents on ferrocement. They assembled and sent hard copies they owned of journals, papers, reports, symposia proceedings, theses, and any other ferrocement document in their possession to Dr. Paul Nedwell at the University of Manchester in the United Kingdom for digitizing. This effort is still ongoing at time of this writing. In 2017, the headquarters of the International Ferrocement Societies were moved to the US, where IFS is officially registered as a non-profit organization. Its website, from which many free and nominally priced documents can be downloaded, provide additional information. Due to the time period between 2006 I remind you that the International Ferrocement Society is a learned non-profit organization dedicated to the whole spectrum of knowledge on ferrocement. In its mission, IFS strives to be a repository for all existing information on ferrocement and making it easily accessible to the public. IFS is working for the benefit of all, including the public at large, with particular attention to the less fortunate portion of that public. At the moment, indeed, self-help construction for low-cost ferrocement housing and small agricultural structures, such as water tank and storage silos, is one of its critical focus areas. An ongoing effort to create example of ferrocement element that do not need costly steps in analysis, design, construction permit, inspection is underway. It's leading to what I call full volume ferrocement, in which we trade off the above costly step, that is, analysis, design, construction permit, and inspection, with a slightly more expensive ferrocement reinforcement. The society's survival and continuous existence is a direct result of an expression of deep faith, enthusiasm, and commitment by a combination of researchers, academics, amateur builders, and businesses who believe in the undeniable benefits of ferrocement. Please continue your work on ferrocement and join us by your efforts to improve this technology. And please accept my warmest wishes for an informative and productive convention. Thank you for your attention.
Dr. Naman, are you there?
Yes,
Yeah. So
yes.
so the auditorium and all the listeners, on their behalf, I sincerely thank you for sending this video presentation. And now over to you for your session.
So could you help me? What do I do?
Sir, you told me that you will be talking after the video
Yes.
presentation. So yeah, we are done with the
So-
video presentation.
So this is my screen. Can you see it?
Not yet, sir.
So how
Wait,
do
I'll give you the control if possible.
This is the screen. I have now my screen full, occupying fully my laptop.
Sir, you will have to share your screen. You will have to go on
All right,
the,
let me go. Show me where should I have. Tell me
you
what
can-
to do.
Are you
no,
seeing the Teams screen? Are you seeing the MS Teams screen?
I'm seeing you,
Yes, on
and
the
I'm
screen.
seeing myself.
Yes, on the top of on the top taskbar, do you see camera, mic, such icons?
I have share. Is
Yes,
that what
yes,
it is?
yes. Click on that share button.
Share.
Yes, sir.
All right. And share what?
Entire
Share
screen.
content.
Share entire screen.
Share entire screen. Well, it doesn't say screen.
Yes.
Okay.
Yes. Yes. Now we see
And
your
now-
screen. Yes. Yes. That's that.
All right. And now I go this way. Do you see that?
Yes, sir.
Okay. So you see me.
Yes, we see you as
All right.
well as your screen.
All right, so I can start if you allow.
Definitely, sir. Most welcome.
All right. Good morning, everyone, and I apologize for this two-part presentation. The second part I title Pre-Engineered Full Volume Ferrocement. It's not really a new ferrocement. It's just a special case that I would like to emphasize. Now, if you remember in my prior presentation, I mentioned that the reason we essentially established the International Ferrocement Society was because we needed to develop a ferrocement model code. So in this slide, I showed that the society, in fact, started in 1991. The ferrocement model code was published in 2001, 10 years later. And we were hoping at that time that some universally big umbrella organizations such as the Uniform Building Code or the American Concrete Institute or RILEM adopt the ferrocement model code so it will be more widely used. However, this did not happen, and it's a long discussion to explain how difficult it can be. But as a result, also acceptance by local building authorities, the local building and inspection was not achieved, and certainly not in the US, I'm not sure in India. So I believe we need to try some newer ideas. And so I try to see how other industries can do it or have been doing it. And essentially what they sell, what they call pre-engineered, in this case, mobile homes, or pre-engineered metal kit shed that you could build at home using simple tools like screwdriver and whatever. And in the case of mobile home, you could buy a unit. It's directly between the manufacturer and you. There is no middleman. And that unit can be almost equipped, almost furnished upon arrival. And you could see some of them, you could have a bigger unit by putting two pieces together eventually. And that, as a result, is that the analysis design is done only once, but there is no need, if you sell 10,000 mobile home or 10,000 prefabricated, pre-kit sheds, there is no need for a permit or an inspection, which are expensive and eventually delay the process. So here I want to suggest a small idea in ferrocement. When we define a ferrocement section, we generally say that the section contains several layers of wire mesh that are uniformly spaced. So the intent is that there is some spacing, as you could see here, clear spacing between the wire mesh. And that is a real problem in practice. If you have asked anybody who has built with his own hand ferrocement, they will tell you that it is very difficult to create a clear spacing consistently. And you may end up in a structure that looks like as built in this past, where a bump happens on your ferrocement mesh, and you end up effectively negating the benefit of the structure. So achieving clear spacing of mesh is not only challenging and costly in real practice, but also prone to errors and accidental mishap in the field. So I would like to propose that we use, at least more consistently, what I call full volume ferrocement. Again, it's not a new ferrocement. It's simply a ferrocement in which the mesh layers are touching each other. There is no clear spacing between them. So the mesh layers form, if you want, a reinforcement cage, and the thickness of the ferrocement element is equal to the thickness of the cage plus the net mortar cover on each side. Now, in analyzing several examples of this full volume ferrocement, I have to give it a name so that way we know what it is, at least for this discussion. I found out it is more efficient to use this configuration, that is when we have a ferrocement in which there is a skeletal steel in the middle, and then the wire mesh is distributed on both sides. This arrangement is generally more efficient when I design several examples. So now what we could do, although we are not selling a prefabricated element like in a mobile home or in a shed, we could work on a pre-designed or pre-engineered element that can be used over certain sizes and over certain arrangements. So what are the advantages of this full volume ferrocement? Of course, the first is a drawback. It's more expensive because you are filling the section with reinforcement. However, the advantages is definitely easiest to build by self-help, non-skilled labor, because there is no possible deviation between the design and the construction. Once you have tied that ferrocement cage together, that's it. That's basically your unit. In that unit, you will have essentially the highest possible volume fraction of reinforcement for the given thickness you have selected, and therefore the highest tensile and bending strength resistances. And because you have a high volume fraction of reinforcement, essentially you will have a high specific surface, which makes the ferrocement more suitable when you are using it for liquid retaining structures. So as a result, we are essentially pre-engineering the element, not necessarily a structure, although once we pre-engineer a structure with something like that, it can be used in multiple cases. So I move to the next section now, going a little bit more into detail, and I'm giving example of what I call this full volume ferrocement. You could see here the configuration. You could see a configuration on this side where it is joined with a rib, but essentially looking at this configuration and looking at element, I show them here on the left column, number 7, 8, 9, 10, look at 9, 10 quickly. And element 10 has 20 millimeter thickness. It means the cage of that element is 18 millimeter, and it has 1 millimeter on top and 1 millimeter on cover on bottom in terms of net cement cover. That element has a skeletal steel. All these elements that I've designed have standard ASTM available reinforcement. In this case, it's a standard ASTM welded wire fabric of square welded of dimension 100 by 100 millimeter. Here we have hexagonal wire mesh, 4 layers of them. Again, the total volume fraction of reinforcement, some of you may not like that part, 3.61%, but that's the only cost we use because we increase the reinforcement, but then we get all the other benefit. So now let me show you something. Oh, here, just an additional information. I designed 25 typical examples with a depth between 10 and 54 millimeter. That covers about all the possible element in ferrocement. I designed 7 with less than 10 millimeter, but mostly the example that are looking like the example I showed in the previous slide are between 10 and 54 millimeter. So now let's look at a real example. In the International Ferrocement Symposium in 2024, I, with a number of colleagues, presented a paper on ferrocement housing shelters. And the idea was to create shelters that eventually become permanent housing. But let's take an example. This is one example where the shelter, you could see the plan view, is about 3.6 meter by 6 meter. Of course, the whole shell part of it is a ferrocement. The outside, if you look at the outside, the roof part looks a little bit like a pagoda. The reason is that it has extended gutters here that collect rainwater. The
Sir,
rainwater
I may
goes
interrupt
into
you
a tank.
here. Sir. Okay, yeah, we got you. I'm sorry.
Rainwater goes into a tank in the back, and the roof can receive solar panel if you need to. There is a possible mezzanine put on top of the kitchen and utilities area for additional storage. And of course, there are other advantages. But let me move to the next section here. This is a cross section of that building or that structure, if you want. And you could see in that section, you look at the walls are made out of the ribs and a ferrocement element. The roof, another rib, and a ferrocement element. So in the structure, we have only two types of rib, roof rib and wall rib, and the same ferrocement element everywhere. The structure, as designed in that paper, and we have all the details, has a 3.6 meter in width, and that can go to 4.5 meter without any change in anything, except, of course, changing the ribs on top, increasing the length, and so on. And the length can be any length you want, because in this case we took 6 meter, but it could be 20 meter or 30 meter because the design doesn't change. So it gives you an idea now of what the flexibility of the full construction can be, because when you build it, there is no way you could make a mistake. You are using exactly the thickness of the ferrocement cage and the thing. So this shows a little bit more details. This is what I call the flat element. This is where the rib element meets the flat element and the details of how the mesh is put. This is a cross section of the wall showing the flat element and the ribs, not to scale, of course. With the rib, the wall is about 150. With the rib, we have about 150 millimeter, but remember the wall is only 20 millimeter. And the distance between ribs is 600 millimeter. Now, this particular element, I took it, and I'm showing you in the next slide just how to design, let's say, a ferrocement tank with that element. So in ferrocement tanks, actually, the design is in a cylindrical tank. It's very simple. There is a formula that ties the height, the radius, or the diameter, and the stress in the hoop direction, which is the maximum stress you get. And using that element that I used for the house, I plugged in the numbers. And for this, for instance, for this water tank, I can look at the bottom here. I could use 3 meter height, radius of 2 meter, or diameter or 4 meter, and that gives me 40 meter cube. But it could be 1 meter high and 6 meter in radius, and that's 120 meter cube, and so on. The formula has a trade-off between several parameters. You could see them here, and one can calculate differently. So the idea is that these ferrocement elements can be designed with their properties as I give, the tensile strength and the bending resistance, and then they can be applied to different structure any way you wish. So I want to conclude. Again, I don't want to take more of my time. Pre-engineered full volume ferrocement examples are immediately available for self-help construction of houses that fall within specified size limits. So in the example that I showed you 3.6 meter by 6, but I said I could go 4.5 up to 20 or 30, and I could go much smaller if I want. The IFS shelter described, again, is, I repeat here the same thing, that we can make it up to 4.5 meter width, and then length can be anything. And I hope that many builders, and whether they are self-help, skilled labor, or others, will implement this idea of full ferrocement, full volume ferrocement approach in practice for housing and common terrestrial structure, such as water tanks, silos, barns, sheds, and the like. And again, to make sure, you will find the paper that I use as an initial description in the proceeding of Ferrocement 14. As I mentioned, these proceedings are being printed. There had been some delay because of some mishap. But in there, you will find a bigger paper or a longer paper with many more details. And I'm sure Professor Nassif, when these are available, will send copies to the Ferrocement Society of India and the authors, of course. And I thank you for your attention. Okay, I'm available. How to go now?
Yes, thank you, Dr. Naman. That was a great presentation. You discussed
Thank you.
the issues faced by the ferrocement constructors and also tried to give possible solutions to that. So I'm sure it will help everyone here, ferrocement enthusiasts. So on behalf of the delegates, I thank you, and I keep the question and answer session open for all. For the online participants, they can put the questions in the chat box. Student volunteers, please reach out to the delegates.
Can you hear me?
Yeah, my name is Milind
Well,
Kulkarni.
you know, I seem to have lost the screen, so I don't see you anymore. But it doesn't matter. If you have some question, it seems like if there are some question that eventually could be sent to me, I'll be happy to respond in writing. But it seems like at the moment I don't hear very well, and I don't see very well anything on your side.
Can you hear us?
Can you
sir?
hear me?
Can you hear us, sir?
I can hear you.
So my name is Milind Kulkarni. I'm a consulting structural engineer in India, Mumbai, practicing for the past 35 years. And I've been a great fan of yours and your work that you've done in ferrocement. And I'm influenced by your work. And we have now taken it ahead from where you stopped at the specific surface and correlating the specific surface to the tensile strengths under the guidance of Dr. Devekar. So we here in India are using your concept of full volume ferrocement also for a very long time. And we have also come to a conclusion where we can calculate the exact tensile strengths of the specimens, exact compressive strengths, the bending stress, the tensile stress, the bending tension, the bending compression, and almost all the values which we connect to the specific surface and the global efficiency factors, and also most importantly the volume fraction. So we have moved ahead a lot now, and we are looking forward to making the first ever comprehensive code for India, which will be, I believe that it will be accepted internationally. So at Milano, we will come up with the code and present the code to you also. And thank you again for all the work that you have done and inspired people like us. Thank you very much, sir.
Well, if I heard well, thank you very much also for your contribution. What I'm hoping is that these elements that you have designed, and I have designed some, eventually we can all put them in a table and standardize them within our society. So anybody can pick up and they would know what is the tensile, the bending, the compression resistance to be expected, and so on and so forth.
We have already
thank you
done
for
that
your
here. We have
interest.
already done that here in India, and we call them capsules. We have tension and compression capsules, and we have put up in a table form, and you can pick up the capsule based on an analysis and forces that you calculate. So we made it very simple now, sir.
Yeah. Thank you.
Thank you. Thank you very much.
Thank you.
Sir, there's one more question in the online chat box, request by Mr. Jayant Patankar. He's requesting that please make available Professor Naman's email address for written questions as suggested. So should we, is it okay to share? We will be sharing it with the delegates in that case.
Thank you. Yes.
Yeah. Another question is about briefing about the fire rating of these panels. The question is from Mr. Gaurav Upadhyay. Naman sir, could you hear the question?
I can't, many times when you talk, I hear interruption with words. So it makes it very difficult for me to hear you. Not you in particular, anybody talking. So I don't know if it's on my side or your side. I do have earphones, so
No, sir. I am saying the question is, can you please brief about fire rating of these panel?
oh, the fire rating requirement that are in all codes eventually depend on the thickness of the concrete element. And of course, if you are thinking fire rating for a large structure, and they will say for a slab you need typically, let's say 10 centimeter for a 2 hours fire rating. Ferrocement, if subjected to a 2-hour fire rating according to STM, the structure will melt. But the structure is typically, in many cases, is not designed for such high fire rating standards. When we are talking about a ferrocement shelter, we are not talking about high-rise building. If there is a fire, there is plenty of time for people on the inside to leave. Just give that as an example. So effectively, fire rating, if we want to apply it to ferrocement, then ferrocement we cannot build. Now, one of the issue that comes in the code is, for instance, and when we try to approach the American Concrete Institute, is that they want a cover to the reinforcement. For instance, in slab, you need to have, let's say, 20 millimeter. But 20 millimeter is the whole thickness of a ferrocement element. So we cannot apply to ferrocement a net cover of 20 millimeter just because of, let's say, corrosion requirement as per the code. So there are certain things that are used for reinforced concrete that we cannot apply for ferrocement. And yes, fire rating of a ferrocement for a 2-hour standard ASTM will fail the fire rating. Okay, I hope I answered your question.
I hope, Gaurav, that answers your question. Okay, anyone else who would like to ask anything?
Yes, thank you.
Anyone else who would like to put up a question? All right, Dr. Naman. For now, I don't see any questions beyond this.
Please
So-
send thanks the audience for me, okay?
The audience is, I thank you on the behalf of the audience.
And I thank the audience for attending this presentation. Thank you very
It is
much.
12 o'clock almost in the US, and Naman sir has remained awake and given us such a fantastic presentation. So I thank you once again, sir, and you have
Thank
a good
you.
night.
Good night.
Yeah. All right. So let's move on to the next session. Please join me in welcoming Mr. Arjun Doshi, founder of Studio Acrobat. Mr. Doshi is an innovator in architectural design who explores the fusion of technology, materials, and creative expression. His work reflects a balance of experimentation and practicality, pushing the boundaries of how we perceive construction systems. May I request the organizing team to kindly felicitate our esteemed guest. Arjun Doshi sir, please on the stage.
Dr. Sujata Mehta will felicitate Arjun Doshi sir.
सर का प्रेजेंटेशन महेश ने डाउनलोड किया था.
This will have to be presenter, display settings. Duplicate slideshow has to shut. So this will be the presenter and that will be the
But it is not clicking. विनायक दादा को बोल दो. विनायक दादा को बुला के लाओ.
This is next, this is previous.
which is it? बंद करायचं सर. डुप्लिकेटच आहे. पीपीटी मधला असेल. पीपीटी याच्यात स्लाइड शो डिस्प्ले सेटिंग्स नाही स्टार्ट करायच्या आधी डिस्प्ले सेटिंग्स.
एक मिनिट थांबा. हे यातनं ओपन करतो.
PDF ट्राय करतो. हां दुसरी PDF थोड़ा क्लिक करो. PDF आहे का? नाही PPT.
PDF ओपन करू सर आपण.
नाही लेफ्टला दिसते ना PPT. हां आली का?
Online participants are able to see the screen. Before I hand over the mic to Arjun Doshi, I welcome Girish Doshi sir and Manish Banker sir with us for the conference. A warm welcome from all of us. Thank you sir. Thank you for joining us. Over to Arjun.
Thank you, Mahesh. Thank you, Ferrocement Society, and thank you, Bnca. Today, I kind of complete a circle. I gave my NATA in the old campus many years back, 2010, and today I am presenting in the same college. I'd never expected this moment will come. So just to start with, I wanted to show where we come from, like how we as a practice started with ferrocement. So at a very young age, I was introduced to ferrocement because of my father, Girish Doshi. And I grew up in this space. This was his old studio, which I grew up in. And this spoke a lot about the space, the form, the volumes, which maybe at that time I did not understand, but later on in my life, it helped me a lot. But I grew up in this space. Our home was attached to this, and I used to spend a lot of time in this space. And then Vidi Joshi, Papaji, Vishnu Joshi, lovingly everyone used to call him Papaji. So at a very young age, we used to visit him because of my father. He was the structural engineer, and he's the one who introduced ferrocement. And a lot of stories which I heard, I never got to work with him, but a lot of stories I heard through my father, through his friends about Vidi Joshi. This is his house on the left in Pune, which my father had the opportunity to stay in, and he told a lot of stories about it. And like there's a silo, water tank, the roof, everything. Like everything was extremely innovative. At that time, they did a very advanced building, which is still standing, called as Arunodaya, wherein they even did this precast staircase. Many people here will relate to this. It was a huge experiment at that time. It had filler slab, hollow concrete block, a lot of experiments in one structure. And this is me in that building during one of the photo shoots. And I spent a lot of time in this building also, because it was very close to where we used to stay, and my father used to spend a lot of time on the site. So as an architect's son, like your weekends are with him on sites. This is one of those sites, Narayangao, which left a mark on me, because this was a huge ferrocement pyramid, which was constructed entirely in ferrocement. At that time, again, they had done a lot of experiment. It was a metal frame structure on which ferrocement was done, including this retaining wall, which was in ferrocement, and it was just with the angle of repose. And this is Bhatt home, which also at that time I got the opportunity to visit, and at a very later date, I got to renovate some part of it. This is Ayyar house, again done by my father. And then I got to, in my teenage, I got to work on this project. This is the lake house done by my father in Mulshi, wherein there was a huge ferrocement roof. I had a hands-on experience on this until I got my first break. This is during my internship with Saurabh Malpani. He got a project for a small office for a lawyer, wherein we did this small shell structure in ferrocement, entirely in ferrocement. And it was a small office, around 125 square feet. As a young architect, I tried everything possible, terrazzo, china mosaic. We even put cups into the, chai cups into the wall to get nice light in. And this is where it kind of started, where I got my first break in terms of ferrocement structure. So we did a huge STP in Hinjewadi. This was inside an existing STP in Hinjewadi. So this was a Portuguese system which the vendor wanted to try. It's a tank-in-tank system. So what you see now there is the inside tank, which is complete, and it's 9 meters in height and 12 meters in diameter. And then there is this outer shell which we did, which was in the helical spring. So we locked 2 helical springs around it, so which entirely got wrapped around it. But while doing this, I got the opportunity to understand the strength of ferrocement. Like it was tank in tank, there was so much water. At that time, I didn't understand the depths of it, but today when I think of it, maybe I wouldn't have done it because there was so much stresses involved, and there was a bridge on top, chain pulley block, all these channels to let the water in, and it was a dynamic load. Till we got our first big architectural project, wherein ferrocement became a language, not because of how ferrocement is, because of the cost part of it. So this is Art of Living Triveni Ashram. So I'll be showing you all these structures which were built in ferrocement. This was the first structure we did there. This was way back in 2011. This was the meditation hall. So this is a 14,000 square feet hall, which is 35 meters by 25 meters, supporting at 4 points. So all our structures were actually designed by engineer Himanshu Tulpule, who has been our support right from the start. When I started Ferrocement, any questions I had, any doubts I had, every time there was an answer. He approached it amazingly. In this image, you can see him. This is Himanshu sir. This is the client, and that's me. And this is the foundation of one of the pillars. So there were 4 pillars, and to reduce the cost, we did it without a tie beam. So there's no tie beam. There are just 4 independent supports. And it was a metal structure, which was entirely built in Chakan at a fabrication store, and then got on site and nut bolted and erected on site. And the skin was in ferrocement. To further reduce cost in this structure, we had used 8 mm torque steel as the binders between. Originally, there was an angle, 50-50 angle, but then we reworked it. Himanshu sir reworked it, and we used this 8 mm bar torque steel as the cross bracing. And then we started casting it. There was a method of casting it also, so that when the structure comes into compression, it is leveled easily. And this is how the shell got completed, and then we covered it with China mosaic on top. The China mosaic was also done in lime to avoid any curing problems. This is how the structure looked once the China mosaic was done. Originally, it was to be only a pavilion, and this is where it was to finish. Like, it was going to be a meditation pavilion, and there was nothing else to be done. Like, people would come in, do meditation, and leave. But then, as the structure was with the organization for some time, they realized that they could also make it into a hall, air condition it. It was never designed like that, so we had to add a lot of elements around it to make it an air conditioned hall. It was again by Vastu, so water element, the weight on one side, and all that had to be taken care of. But this is how the structure was. Only the skin was in ferrocement, entirely in steel, and on top of that, it was a shell ferrocement skin on top. After that, we added doors and we added air conditioning through the ground. We did radiant cooling, and many elements were added into it to make it air conditioned. And then budget increased, so we made an entry. There was an entry which was coming to you enter the project. So the tunnel was, we made a tunnel in it, and again in ferrocement, and just to add landscape elements into it. So once this was complete, we started getting other projects, because as the hall came in, people started visiting, and the requirements grew. So there was a need of new kitchen, there was a need of new toilet blocks. So 14,000 square feet, originally we had planned around 250 people to fit in, but they could fit in close to 600 people in it. So they needed a heavy use toilet. And with Vastu, how do you design a heavy use toilet? So it becomes like a railway bogie, you know, like a longer unit. So we made a round unit, entirely in ferrocement. Only the outer skin we kept where the plumbing was going to be in brickwork. Everything else was in ferrocement. And we put Ghotai IPS on it. This is how the toilet blocks looks, ladies and gents, 2 toilet blocks beside each other. Then we got a housing. So 9 was their auspicious number. So they needed 9 rooms for ashramites. So how do you fit in 9 rooms in front of each other? So what we did is we skewed the first 4 rooms, and the behind 5 rooms stayed straight. So we got a design within that. We tried in this to even make the furniture, the inbuilt furniture, entirely in ferrocement. Even the benches outside, the walls, everything was in ferrocement. And at this point, we had come to a situation where the client had started complaining about all the small wastages left out of ferrocement. So the mesh and the chicken mesh which we use, when you do curved structure, or there are ends left, which they were collecting and keeping. So we thought we could propose them a retaining wall, and they wanted one more housing at that time, which then later on got changed into dormitory. So the same logic of the STP we used here, and we made this retaining wall this thin, just around 2 inches thick in ferrocement by the helical method. And we made these boxes, coffers ahead of it. These are all 600 by 600 coffer. Then filled it up on ground. So this is that retaining wall around. Filled it up with murum. Murum was available on site. It's in the near Alandi, where there is a lot of soft rock available. And then we made this on-ground foundations, just ferrocement beams again and ferrocement columns, and we made this shell on top of it. So the idea was to achieve maximum space and minimum material. So this tank also was at that time designed by V.D. Joshi. This is, we call it ball tank, but this is 15 meters head, 6 meters diameter ball, and we made 2 of these tanks on this. This was designed by V.D. Joshi. We are just repeating them now. And then the shell kept on repeating. So that little reinforcement, just 8 mm torque steel, and in 1 by 300 by 300 grid, welded mesh and chicken mesh on top of it. And the folded plate could work, and we had this huge span. So this was 24 feet by 8 feet on this side, and on the other side it was 34 feet. And we started casting it. Again, as suggested by Himanshu Star, we started from the outer side and came into the inner side. And this is how the shells look now. To strengthen the column, we even did a plus column. So you can see here, we had done a plus column just to strengthen it like ribs. And this is how the shell looks now. That's the water tank behind. And Himanshu sir suggested that we keep one shell small, because if anything goes wrong, we cast this last, and then that's where all the corrections can be done. But luckily we had no trouble. Client was impressed with the economics, not means he liked the design, but morely economics. So we did one more unit, which was smaller than this, but we used the same proportion. So it has become a little aggressive. And so then they named it the gents dormitory and the ladies dormitory. So we had 2 dormitories side by side. And while this dormitory was going on, they said, now we need a washroom also, because we don't want to use the other washroom. So we added a washroom in between. This was entirely unplanned. They were thinking somewhere else, but then we fit in a, so how do you fit in a heavy use washroom right between such a tight space? So what we did is we did like a spiral entry. So these are a few images of the dormitory and the retaining walls. At some points, the retaining wall is as high as 14 feet, 4.2 meters. This is how the shell looks after China mosaic is complete. This is the inside view. We did the window also, like how Girish sir used to design his windows in plywood, just to reduce the cost as much as possible. And it was only an 8 p.m. to 8 a.m. usage. So people used to just come here to sleep. So this is that heavy use toilet. So we made it into a spiral form. So longer the call, deeper you go. So that was the idea. So it's just like a spiral, you enter. And we made one shell which started from the outer side and came into the inner side. Wherever there was plumbing running, we did regular brick wall. And all the other walls, we had ferrocement. So all the services were put on the brick wall. And to improve the ventilation, because it was back-to-back toilets, we gave one skylight to every cubicle. And it was in a V form, so the entry door was smaller, but as you go in, it is larger. So this is that spiral. So you come out like this, and this is the entry. And this is we tried a reverse dome here. So it was like a ring which we tied at the end, which would hold it like a woven basket. It would hold everything together. This is that reverse ring, again designed by Himanshu sir. All these works are designed by Himanshu sir. And these are all the cubicles around it. And this is the ladies' toilet, which is on the outer periphery. So there were showers and WCs in one line. So what we tried to do, how we solved the Vastu part of it, is that we put WCs where they were permitted. Everything else came wherever it was not permitted. After this was done, they needed one more housing where they wanted one room where it could have a small kitchen and structure, but they really liked the shells and the economics of it. So we used the same proportions of the shell and we tried to make a room. So this was our approach. So we made a central column which housed everything, and the outer column became very lightweight. very thin, and it came all the way up to 900 mm. And this is how the shell looked. We added the ribs not for strength, but to accommodate any kind of door, window, any jams. So it was in plumb, because the shell, all the shells which you are seeing are at least 20 to 30 degrees falling on the outer side to hold the shell from the other side. So this is not in plumb, this comes out, but the rib is in plumb. So you can attach any door, windows. That time they wanted one room, but as the construction went on, they realized it's very big, we can make it into 2 rooms. So we divided it into 2 rooms with brickwork, but this is how the structure looked. And during this conversation, we added an entry. So they were looking at some grand entry wherein people come in through a huge entry, huge door, and enter. So we proposed this, and they liked it, and we ended up constructing. So we just made a small pavilion, like a pause. People come in, register, and go ahead. So again, very thin sections of ferrocement were used. Only ribs or only ferrocement walls were used to entirely do the structure, and we did ghotai on top of it, IPS on top of it, to finish the structure. This is how the entry looked while construction, and this is how it looks now. And this is the security cabin, and this is the entry. No gate, nothing, just you enter through a pavilion. This small video. Okay, maybe it's not playing, we can see it later on. There's a small video of the ashram, drone shoot, where you actually see all the structures. During this, so many people visited Markal ashram for various reasons and various functions. One of our clients, which we got to do this project, also visited, and they really liked how the structures had come up. So they invited us to do this sports complex. So this was our proposal. So this is in Maswad. This is close to Pandharpur. It's a very hot and arid region. It rains very less. This is for the Dhangar community. It is for a foundation called as Mandeshi Foundation. So this is the sports complex. These are the dormitories. These are the senior girls' dormitories. This is a big hall. Under that is all the kitchen, dining, classrooms and everything. So they already had 4 Olympians when we got this project. So this was a very heavy use plan in a very small area. So this was the entry. From here you come to the main stadium. This is 1 dormitory, 2 dormitory, toilet block, the senior women's stay. These are all the services and classrooms. This is garden area, and this is an amphitheater right at the end. We put in an STP under the stage, and here we have the coach stay. And this is toilets for the visitors, and this is the cafeteria. So this entire project was designed and was worked on by only one girl from our studio, Sneha. She's also from Bnca. So when we visited their office for discussion couple of times, we used to always see these images put up in their office. So this is a chowni for all the Dhangar shelter. So we took some inspiration from this and designed the dormitories. So until now we had designed all our shells absolutely geometrically. So here we got an opportunity to design geometrically but in a random form. So the approach was that we have minimal touch points on the wall, and so a lot of air flows in, and it's like a very lightweight structure which is just kept onto the roof. So no windows, but a lot of air travels through. That's the stadium behind. This is how the shell was made, and this is how the shell looks. And then we started casting it. A lot of skylights we added in to get in a lot of light. Some skylights were for plantation. And on the higher side, we made these arches so that wind could flow from all directions. So you have very good wind flow. Regular brick structure. So it's entirely load-bearing walls, no columns were there. On that, there's just a tie beam, another tie beam for the ferrocement to start. And this is how the shell looks. These are some of the openings. This is another dormitory with the skylight. This is how the shells look from outside. So they get all privacy also. The behind the elder girls' dormit stays there, which was made in brickwork. But this complete roof, because this was the stadium area, so we wanted privacy also. It was a contour site, so they get their privacy. At the same time, you don't see many buildings, you just see a shell. And we had a huge goat farm right beside us, so we wanted to barricade that also. This is also a video. Okay, please. Oh, okay. Achha. No problem. So we just had a video of a person walking on the shell. So then we took this is the logo, the Mandeshi logo. So we took the inspiration from there for the China mosaic and worked out a sari pattern. It's very windy most of the year. It's entirely arid. So close to Pune, just 4 hours away from here, completely barren. Absolutely no trees, extremely hot, doesn't rain, very little monsoon. And this is the China mosaic being executed. It's still under construction. It is entirely funded. The organization is getting funds from wherever they can and completing the project. The main roof is now left, the stadium roof. But as and when we get funds, we are trying to finish whichever part we can. These are all the skylights for the toilets. Under these are the toilets. So again, we did the same thing here. We added one skylight per cubicle. And this was only for girls. So we had to take care of the security. And these are all the girls who are from Dhangar background, whose parents are from a very normal living. So for them also to leave the girls and send them to this facility to work, it had to be absolutely safe. So we designed it in such a manner that you could lock 2 gates and the entire structure could get, the entire area where the girls move around could get locked or secured. These are how the shells look from inside. There were courtyards also, plantation courtyards also, where they could come and sit in the evening. The benches still left. And at this point, we were lucky to get a project which we'd always dreamt of, but we never thought any client would accept. So this is in Navsari, close to Surat. This is a bungalow in collaboration with a design firm from Surat called as DWG Design Work Group. We are doing a bungalow for a client from Surat. It's a second home. When he approached us, he said he wants a free-flowing home, and he gave us examples of Roth and showed us some images. We thought it's a dream project. I don't think the client will ever accept. But then also we had to design something and show it to him for him to accept, to start the conversation. So these were our initial watercolors, which we did, sketches and watercolors which we did for the client. And we thought maybe he will be interested, maybe he will not be. But every time he used to see one sketch was enough for him, and he used to talk about it for 2 hours and discuss, and we used to draw, and eventually we came up with a plan, a workable plan, and things started really moving. And so this was all in sketch form. So a lot of things were exaggerated, and a lot of things were maybe you can't construct and stuff like that. It was just a proposal. But then we had to get it in a little, like metric form kind of a thing. So what we did is, how do you do 3Ds for this? Because none of the softwares work properly when you have to do such kind of structures. So best is AutoCAD, and now thanks to iPad, what we did is we put the plan under it and we drew on top of it to get proportions correct and for client to also accept, because making models, physical models also becomes very difficult. So again, this is all creation of Sneha. She tried and worked this out, and it's worked out amazing. And then we got it onto drawing, actual CAD drawing, AutoCAD drawing, and things got moving, and this is the whole home. So the outer shell, actually it's a scheme in Awadh Ayushka. This is in Navsari, which is a 350 bungalow society designed by Tony Joseph. And it's a Kerala home theme. And inside the box, the client gave us to play. So this outer shell was decided by the builder and the architect's builder. And the inner forms is all we have designed. So once that shell was ready, they gave us the structure and we started working inside. And this is the plan. Today, like always, we get this question a lot, like how do we transfer it on site, and how do the drawings go on site, and how things work out, which softwares do we use. So until this project also, we were working with our team, our own team. We had a team of Ferrocement from Pain, which Papaji used to use originally, and then we were lucky enough to use them. And so they used to work for us, but this was in Surat. Professional client, professional contractor was needed. So client shortlisted a couple of contractors, and eventually Nagnath sir got this project, and he from Pune is executing this project. So when we met for the first meeting, these are the drawings. We showed it to him, and we told him that yes, all drawings are ready. You can immediately start work. And we showed him all this, and he liked it, and he said, "These are great. Send me the drawings, and I'll go with my team and we'll start." So he reached Navsari with his 50-60 people team, and he reached on site, did the line out and started working. 2-3 days into working, he said that you need to come, there are a lot of discrepancies we need to check. And we realized that these drawings were not enough, and it was a lot of back and forth. Like every time there was a problem, we had to go on site, because all the drawings, majorly what we had done were actually presentation drawings. You know, this is how we want the shell. We were just going on site, and on our own sites we used to do like aisa kar do, vaisa kar do, and they used to do it. Like we had proportions in our mind, but we could correct things on site. But with this so free flowing, it was very difficult. And with a very professional contractor like Nagnath, it was becoming very difficult for his team also to execute, because they were looking at drawings and they were like, like half the things are not mentioned in it. What happens here, what happens? And this is one time. Like once the ferrocement is casted, you can't break it and redo. It's not like POP, like you can keep on changing. So none of the forms were same. All the forms are free flowing. So we realized that we need to go back to the drawing board and redo all the drawings. And so that's when we worked out a drawing system for this. This is a mezzanine within the ferrocement shell. So I'll show you one set of drawings for only one rooms. We were close to making 60-70 drawings per room, and there are close to 16 rooms in total. This is the staircase block. The slab had to be in RCC because the builder was doing it. So if you see, the outer face is the builder work. He did everything and gave it to us, and then we started working reverse inside. So it's structured within a structure. We worked out a door frame. So the client had very heavy requirements. Entire structure had to be air conditioned, centrally air conditioned. So ducting for it had to be hidden in ferrocement. No other material was permitted. All his permissions for this requirements for door, windows, everything had to be accommodated. So I'll just run you through the drawings. So these are the drawings. So we made, this is the list, because there were so many people involved, we needed everyone's approval, including our contractor, Nagnath sir, because he had to eventually execute it. So there were water bodies. I'll just run you through these. These are set out plans. Each and every measurement had to be given, because this is how they were going to execute it on site as well. And we made a grid. So there's a grid, there's a 1 by 300 by 300 grid to the entire structure. These are the plans. And during this structure, we realized that while working on the drawings, that drawing itself can be so interesting. All the drawings became so amazing, especially the sections. We even added the structural engineer's drawings, Himanshu sir's drawing. Again, Himanshu sir is working on this. So even his drawing, his detail were put into that one set. So every time you go on site, and we worked out everything on A3. So these are the sections. While looking at these sections also, we were like, this is enough, you know, like even as a, just like a practice, like this is enough, let's keep it like this only. So these are the shells. So we worked out the cell at 50 scale, we printed it. Then for detailing, 25 scale was required. So we cut the shell and printed it in 25 scale, and all these drawings were sent on site. And this is the first room we did. And now there are, I think, 6, 7 rooms are complete. All the openings also, outside opening, inside opening, how the windows will work. There was a pool, there's a pool, every room has a pool, jacuzzi, very heavy use. They needed a slide also in this. We worked out a slide. This is the slide. The water should run on the slide. Everything the client used to discuss with us. And it still discusses. Everything he'll come on site, spend a couple of hours, how the door will be, how will it open. Yeah. The plumbing drawings also, how the plumbing was accommodated, because everything had to be incorporated. This is like the final finish. In this, there was no one else going to work after this, including the interior. Like, this is where the interior would end. So, like, all the furniture was also in ferrocement. Only one material. Only in some places we are putting wood on top of it. Thank you.
Thank you, Arjun. That was a fantastic presentation. So beautiful, so insightful. Kept the audience glued to their seats. Now we keep the session open for question and answers. If anyone from online meeting or in person want to ask questions to Arjun sir, please put in a chat box for the online participants. For the offline participants, they may just raise their hand. Volunteers will come with a mic to them. Yes, there's a question by Bnca sir.
Arjun, amazing work and such a good extensive ferrocrete work I have not seen before, and this is truly inspiring.
Thank you, sir.
I have only question about how do you manage the thermal insulation over this roof?
So, luckily for all the ferrocement work which we did in Merkel, most of the shells we did China mosaic. Means all of the shells we did China mosaic, and the volume was quite a lot. So, wind used to flow. It was cross ventilated, so the shells used to not get heated, much heated. But in Surat, like I think for the Surat project, we need to spend 1 hour session only on Surat project. In Surat, we are doing insulation, so we are doing something called as a double roof. So we have a ferrocement roof. So all the bars which you saw in the images are actually going to be ribs. So it becomes like a coffer. In that we put insulation, and again on top of that there is ferrocement roof. So the inside shell and the external shell are both not aligned. Like if you see in the section, they are all different. So the water also had to flow out. It's in Navsari, very heavy rainfall is there. It's like coastal, means Konkan, so the rain is very heavy. So we have to take care of that. And on top of that, again, we are doing PU insulation. Until now, all the projects which we did, ferrocement was looked at it as a cost. Like ferrocement was being accepted because we could do it at a low cost. In Surat, it was entirely different. It was reverse. We are doing ferrocement as a art piece, you know. So whatever money is required, they were willing to spend. The door, actually I didn't elaborate on it, the doors also in ferrocement. It has a face ID. It has everything possible. You can think of it, none of the windows open. Like that client is a very famous industrialist from Surat. So he has his own ideas about how he wants his building. So the outside window was different, inside window was different, how the curtains fit into it, how you do the blackout, everything was worked out. Even the skylight, they want blackout. So even that is worked out.
Wow, great, thank you.
Any other questions from the audience? Yes, back there, students.
When we did the hall, meditation hall, we actually had two people, means it was a 3 people team. It was Saili, Neeraja and me. All three of us started the hall and completed the hall, meditation hall originally. Saili is also from Bnca. I'm not sure if she's there today.
Hello.
Yes, you can stand up and ask the question.
Yes, Ashu. You saw one of the pictures where you make a hall and there was air conditioning involved in it. So what was the need to make the hall air conditioning? It was like open roof and the water was,
Which one? For meditation hall?
yeah, and the near there was water bodies also. So why you put system for air conditioning there?
So actually, that was something. Actually, that is air conditioning was designed by R.S. Kulkarni. He's a very well-known HVAC consultant in Pune. So basically, what he did is that hall could have. He did a 100% fresh air system, wherein none of the air was recirculated. So it was a 3 system air conditioning. So what you saw was actually getting in the fresh air inside. That was a 2-stage evaporative cooling system, wherein we got the air through the hume pipes from the ground because the shell was already done and it couldn't take the weight. It was an afterthought. The air conditioning was an afterthought. So we had those nozzles just to pass the air on the top. Then there was a huge fan, HVLS fan, which used to push the air down. And in the ground, we had done radiant cooling. So it's a 100% fresh air system. Why the water on the north? Because that is where the water used to flow. And as per Vastu also it was perfect. But what we did is, we used the same water in our chiller plant. So the water used to start from the waterfalls, fall, cool over there, go into the chiller plant, go into the 2-stage evaporative cooling system, go through the filter, and again out into the waterfall. So every time the air conditioning used to start, we used to have a free waterfall. So it was a complete recirculation. And the same we did for the water tank also. They used to do irrigation from the river. So till the water tank, they had a 7.5 HP pump, which used to break at that waterfall. So every time the water pump used to switch on, we used to have a waterfall.
And
So
also
it's actually a fresh air system.
and also one more question. Why do we use that? Why do you use why don't you use ferrocement technology for plumbing system also?
Sorry, for plumbing.
Yeah.
Actually, water tanks is the very common thing, which ferrocement, if you see today also in Pune, maximum, or in India, even in Mexico today, maximum you just put in ferrocement, water tank, you'll get thousands of videos. So it's the most common thing you can do in ferrocement is water tank. I also started my career as a contractor in water tanks. I used to build water tanks for my father and a few architects, his architect friends. For water tank, internal walls, staircase is the 3 most common things which you can apply. Plumbing as a material, maybe because the diameter is small, you can make huge pipes, but then you have hume pipes available in the market which may work out cheaper. We have done a lot of STPs also in ferrocement. You saw one big, but the smaller ones also can be done. STPs can be done. You can even do small septic tanks also in it. So in plumbing, ferrocement has maximum use. So idea that you can just take a bundle inside a room and construct anything there and leave it there. So you don't have to take very huge shuttering or anything.
Thank you.
Hello, sir. One more question. What role does mesh geometry, square, hexagonal, play in mechanical performance?
Sorry?
So, what role does mesh geometry, square, hexagonal, in perspective of mechanical?
So basically, welded mesh, when welded to each other, it's a rib. So that rib creates a lot of strength. Now, that rib can be in any form. It can be hexagonal, square. Welded mesh, fortunately, we get only in square format. So, but until now, we were using welded mesh, and on top of that, chicken mesh. Chicken mesh was majorly to hold the mortar, the cement mortar, which we apply on the ferrocement. But now that we are working with Nagnath in Surat, we realize we can only do it in welded mesh also. What he uses is, you have a sample outside, he uses only a 1 inch by 1 inch GI mesh. So there you're not using any chicken mesh. So it's just reinforcement on top of that mesh, and we are casting it directly, and the finish is superb. So the role of it is the actual binder. The torque steel is just like a formwork, the frame, but the actual mesh is getting the whole strength to it.
I see a few questions in the chat window. Rate of per square feet construction cost of the Surat project, if he wants to reveal.
Yeah, absolutely. So it is around 350 to 400 rupees per square feet for the ferrocement structure per se, and then all the other finishes are on top of it. But what we are doing is right now only we're finishing the mortar in such a manner that's the final finish. Like we are doing it in IPS entirely, so that sand finish is the final finish. Nothing is going to come on top of it except for a sealer.
That's the second question.
How the joint
How
are
the
done?
joints?
Brick wall. So joints between brick wall and ferrocement are very tricky. They need to be handled very well. It entirely depends on what kind of brick we are using. Unfortunately, in this region of Maharashtra, we get very bad bricks. But as you go north towards northern Maharashtra, you get some amazing, very strength-centric bricks. So what we've used in Mksss are some really good quality bricks. And on top of that, the beam was tied into it, anchored into it, up to 600 mm. At every, again 600 mm. There's a drawing for it also. I have not shown it today, but there was an anchoring method.
I guess that answers all the questions of offline and online participants. We will take the questions later. Abhilasha, you can talk to sir later. I'm so sorry. We have to move on to our next session and the next speaker. We welcome architect Manish Banker on stage. Manish sir he is a stalwart in Indian architecture, graduated from the Institute of Environmental Design, Vallabh Vidyanagar, Gujarat. Banker sir is the founder of Tao Architects Private Limited, Pune. His work focuses on organic architecture, sustainability, and innovative material use. He has received recognitions from Asia Pacific Property Awards, Triple ID, BAI, Artists in Concrete, All India Stone Architectural Awards, and ASA. I welcome architect Manish Banker on the stage, and I welcome our convener Dr. Kalyan Sundaram on the stage to felicitate Banker sir. You may keep it near his chair, okay?
Can you start with the slide? No, I think I'll go up there. ऊपर से जाओ. No problem. You want this? Yeah. Does it work? Yes. Play करो.
This is next and this is previous. It will work. When the presentation starts. Yes. Wait.
There are a lot of online participants as well, so we need to share the screen for them as well.
No, so you started, no problem. So if anything...
Sir, you would like to stand and speak or sit and speak?
No, I stand up.
Okay.
You want to sit there?
No, it's absolutely Acha, and how do... Acha. Right from there. Hello. Good morning, everybody. The people who are sitting here in the hall and of the people sitting somewhere else. And this good digital advantage to have people seeing this event even from quite a good distance. So I welcome everybody, not only sitting here, but sitting maybe at their home or offices or any other institutes. Good morning, everybody, and I'm quite glad to be among all of you here. And I thank to the Ferrocement Society, the Bnca, extending this honor by inviting us to present this little presentation here, which is more related to ferrocrete. And I'll just yes. Okay, meanwhile we set this screen. I truly appreciate works of Arjun. Doshi has done really remarkable work, quite extensive work on ferrocrete, which is worth clapping for. And I'm sure it must have inspired many young chaps sitting here to see that technology is quite extensively available at the service of architecture, and how you actually mold and use the various different technology to really formulate a good architecture. I'll just introduce myself. I graduated from the Institute of Environmental Design, Vidyanagar, and I did my research thesis on organic architecture. And while studying works of Frank Lloyd Wright, and Nari Gandhi as an architect based out from India, and quite a good inspirations while reading many books written by Frank Lloyd Wright. Then ended up at Pune, Osho Community International, as an apprentice to spend about 3 years under various different architects, designers, engineers from all over the globe. I do enjoy traveling, sketching as my hobby to explore what kind of built environments being generated all over the world and how you learn from them while you being student forever. So there are various different spaces, which you actually capture more as your, and this was one of the first project we did in Pune in '95. And right now we have a team of about 30 people having a practice managing some of the projects. We've been recognized from different kind of projects, but some of the residences, even the high-rise buildings. So we've been involved in a different nature of works to actually see that we explore different possibilities while being an architect and designer, to see that. And they also, some of the hospitality projects also includes. But today I'm here to share a topic called technologies, which are always innovate to serve architecture. So architecture is, of course, the final, it's like how doctor is concerned about the health. But the technologies in form of pharmacy exist. What you really pick up for what disease, what problems of human being is something which I think relates to architecture, that we as architects are supposed to know and talk about, learn about the final solution. But what kind of technologies to adopt is something relevant to each and every different problems coming to us. I would like to introduce today the project we recently completed called Swastik, which is a well-being center around Khadakwasla Lake, which overlooks the Khadakwasla Lake, and also has been well placed very close to NDA. And basically, and it was the time when we got project was COVID time, and there were a lot of health conscious approaches were being considered especially in the architecture and various other projects. But primarily what we realize that we as human beings work with the two different aspects. We got a body which is a hardware, but we got something to apply to live our life is a software. And our software is the understanding by which we actually inculcate the life, infuse the life within our own process of living. And there is a well-being which is at that utmost. The environment what we create as architects is something which is more important than the forms we generate. So the forms are not as important as the environment what we create. The spaces which would help people to create a better environment for every human being, and not only human being, but the entire existential phenomena, including the nature, animals, birds, and various other aspects, which holds all of us together. The project Swastik had, of course, it was designed right from the beginning, its own logo, and it was derived by the swastik and the flower, blooming flower. And this was the kind of a 4 + 4, 8, and the center, the 9th, was the element, to create the logo. And we picked up the logo with a different, and then each petal had its own purpose to actually serve there. And then the whole function and the program of the project rotated around the logo and its meaning, which held the entire project together to provide a well-being. And we actually created even the 5 elements also when we could visualize the 5 elements as a part of the program. And before that, if you look at over there, then we got a 5 senses also to include. And they are all various human-related aspects which are quite important to inculcate into our design process. This is the site when we got to have a look at it, which overlooks to the Khadakwasla Lake. And if you carefully see that this is the site and it overlooks the Khadakwasla on this side, that's the north on this side. And we had a hill, so this is actually a valley all around if you look at the contours. And this is the highest side where it goes almost towards the west and the northern side, where the eastern side was dropping down and all the water would collect here and flow down back to the Khadakwasla Lake. And we started thinking of the layout. Now here, my idea is to show that there were 5 major built forms we had to create to attend various different program of the project. The first was the Anand Vihar, which was here. This is the second one is a Ayu Vihar, where all the various kind of Ayurvedic and naturopathy treatments going to be served there. And then we had to also put some of the residencies for people to stay as cottages. So we planned it out them here within the hills here. And we also planned to create a Ganga Vihar, which is basically the water reservoir. We collect the rainwater and channelize them all the way down to here. We collect the water and we use that as a kind of a Ganga Vihar, where we create a very sacred space for people to do, some kind of prayers, and ultimately let the water go down back to the lake there. And the 5th phenomena was to create a meditation hall. We named them Dhyan Vihar, which represents the space, and it basically was meant to have a large congregation of people meditating, various different programs, therapies, yoga, and etc. This was the site when we got it. It was in this condition, overlooking to the Sahyadri Hill. That's a Singhgarh Fort, and this is where the lake, Khadakwasla Lake, is seen, can see here. So this was a kind of a raw condition, but it's a beautiful valley which I could visualize that it had a good basin to capture as primarily architecture, because I felt that the valley itself was enough to formulate a beautiful space to hold the entire project together. And then we have to just simply align those various functions to ensure that each one of them are at a distance required, but at the same time they have they hold themselves together, overlooking towards this backwater of Khadakwasla and the distant hill Sahyadri range. And this was the view of the site. This was the further up when you go up to the hill. And if you look at here, see this was a quite flat land here at the lower part. And as you rise up here, the hillock here and many trees here. And we wanted to not cut any tree. I mean, these photos are taken in a way that there are a lot of dense forests, but some of them trees were not, actually they are only they come up during the monsoon. But big trees were all retained, and if you look at that entire hill, we thought that we would somehow use this hill in benefit of the project, which we eventually will see that. And this is how we planned out the entire project, wherein this is the Dhyan Mandir, and this was the visualization we had done, and this is the Anand Vihar, where all the different functions of the arrival, reception, various auditorium and workshops and the hydrotherapy and VSC, and these are all IVR, where the functions like naturopathy and Ayurvedic treatments and therapies have been performed here. So we had to put different sections, and if you look at them, the courtyards are used in a way so that we could somehow retain the trees, and the buildings were designed in a way that we could hinge them based on where the trees are. And this is the actual picture. This is a drone camera looking at the actual project. This is the site plan. We had Anand Vihar as the main arrival, where you go all the way up there here, and then actually enter into the project and overlook, the entire site, of course, and along with the Khadakwasla lake. Now see here, this Dhyan Vihar I will start with, where again I'll come to the technology, that why this Dhyan Vihar had a large congregation. We needed only 11,000 square feet of a hall without any obstructions, visual obstructions. And so we chose to have a tensile roof as a technology, which would help us to get natural light. And we created a cross-ventilated, so if you look at this, there are courtyards created around here to fit various services and structural elements. The 4 structural elements which would act as a kind of a frame to hang the entire roof. Now this made the entire hall simple. So the roof and ceiling became the same, but at the same time it gives immense amount of natural light right under the hall on the floor. And having a cross-ventilated courtyards like this help us to generate a ventilation, wherein if you look at it carefully, the section shows that the hot air rises up. There is a chimney created here on the top, so that the hot air would escape out and would help creating a passive ventilation system within the hall. So you actually get a cool air coming from the garden into the hall, rising up that, and also at the same time it will cross-ventilate. So, and for the summer time, we also provided this channel here to create a mist system, so where we don't need to put air conditioners there. And Idea was to avoid energy consumptions, if preferably, and somehow we could manage it well. We could also get a natural light, natural ventilation, and created a large congregated space for people to come and sit and meditate there. The other part of the project is the Anand Vihar, where we had to, of course, handle a technology by creating the kind of a cascading down building to ensure that we use an RCC block, but the large spans would create by the metal structures. So we adopted, the metal frames, and with a very thin skin of cement boards, with the insulation layer on top and the finishing layer at the bottom, and somehow we could achieve the form without having much of the load on a structure, and at the same time we could get a large spans. And similarly we did the other building. Again, see, it was hinged in a way that this is the central part where people could arrive, and then they'll be distributed as men and women section. But if you look at that, they are not equally hinged, because we had to see that we retain these existing trees and we orient them in a way that we would have tree as part of our garden. And then this fourth part was the Sukh Vihar, where actually it is meant for people to come and stay there. We had to create a cottages and spaces for people to stay. And this is where the technology we adopted was a ferrocrete. So each function had their own little reason why we chose particular technology. And this one, I knew about ferrocrete, but we did not have much of an exposure. And but I thought that this would be the ideal condition to retain the existing trees, which were all existing here, and we would formulate a section so that the people from the level above would have a view without any obstructions, and we will have access from various different levels to see that, and we could formulate a different typology of cottages with their different sections and formats, so that we can have use this entire hill as our hidden caves. And I somehow visualize that they are not actually cottages but the caves to live in, and we had to formulate them in a way that they hug the ground. And this was the idea, that how do we actually use ferrocrete as a free-flowing forms, but at the same time get well insulated by the garden, and they remain hidden. And each cottage actually are hidden gems or guhas, or to actually get inside. And of course we had to manage different light through the skylights, the ventilation chimneys, like that. And then they would actually serve the purpose of having light ventilation, but the view would open towards the east and west side. And this is how the formulation started, having one by one. But it was not that easy. And but this was, to come to this point, this was the first ever sketch we made. And was quite difficult to actually see that how do we fix each cottage. But somehow this sketch gave confidence to the client that we can manage with the chimneys and and the openings like that, and all of them looking at, and there are hills here, hills at the lower level, and we could somehow put various different openings entering into the hill as a space to be carved out. And the idea of that these are the places for the seekers and meditators to come. So it was not just one of any kind of idea was to sell a different kind of an experience. So when you have a different kind of experience to share, people coming from urban scenarios, more influenced by the industrialized formula of the rectangles and squares and corners, here we thought we'll give them a very rural sort of a nature, and they would simply love to get more close to the nature. And each cottage was visualized more like a womb of Mother Earth. And how do we see that people actually rest well, get more in contact with the Mother Earth, and see that they rest well with a well-nourished environment. So these all sketches were quite easy to draft out. The real issue came when we had to see the detailed sections. We started working upon getting the light and the plumbing shafts, various engineering shafts to be put, and we thought we'll create a kind of a space where the people even having a mezzanine maybe can overlook there. We created a veranda to look out there, and this is the kind of sketches. And of course, we kept on sketching. The sections were basically to see that how do we use the natural ground and slope. So we did not fix the plan. We also kept on making different formats. For instance, this is a one type of plan where you have a stairwell and you go up there and have a mezzanine like this here in the section. But in some cases we did not go with the mezzanine. You come in veranda, have a lower sections. So we created 4 type of modules to fit based on where the trees are, where the slopes are, where the access are, and we kept on arranging them considering the location of the trees. This is the beauty of a ferrocrete, that a ferrocrete gives you so much flexibility. It is one of the most interesting and artistic and handcrafted technology to be adopted. And we of course went on doing the details, like how Arjun also showed, that you have to create a grids and give a lot of drawings and details so that people who are executing the work will get a kind of understanding and ease, because they are somewhere on the side and it's not that easy how we see sitting in the air-conditioned hall looking at the drawing. When you see on a side where it's raining, harsh sun, slopes, dust line, and I must appreciate Nand Kumar Jadhav, who is sitting here in the hall today. Where is he? I would like him to get up. And he was the first person, I must clap for him, that he stood by our ideas. He was the first person who gave confidence to the client that yes, this is doable. Till then, client thought these are crazy sketches, they are not going to get executed, and who will do this, how will do it. Even the structural engineer also raised their hand that we cannot manage this, because there is no technology which will actually ensure the stability of a structure. Now, structural engineers also so succumb to the computerized measurement of the structural stability that they would not take a risk of this. And as Arjun also mentioned, Talpule somehow came to rescue our idea that yes, this is doable. He says, I will give certificate. But they say, who will? He says, I am giving a certificate that this will stay. There is nothing else. I mean, we didn't have initially, when we did the temples, we didn't have any structural stability certificates. But they existed even more than 1,000 years and still exist. So this is something which we had to put the idea across. And so we as a team of architects, Jadhav as a team of contractor, and the Talpule as a team of structural consultant had to somehow win the confidence of clients. And finally we decided to go with the first one cottage as a sample. We did all our best to create model which was so difficult to digitalize the idea. Normally it's very easy, and this probably also the limitation of our technology, that it doesn't generate as clarity with such kind of a free-flowing forms. But I appreciate my team who did their best. We took almost 2 months to create one little model like this, and somehow we could manage it to convince the clients that this is how it is going to be done. Still, there are a lot of ifs and buts, but we could somehow hold our fort together to ensure that client gets convinced for at least doing one little cottage. And we started off this. Structural consultant gave a very heavy foundation because they were so reluctant to do this, okay? But we somehow told them that no, we must. So I said, first cottage, we logged up whatever you say. And we started working around that. We added this wire mesh to create the form what we had visualized in 3D. And we kept on doing this and holding, the old ideas. Slowly people started realizing this is doable. And this is the time Nandakumar Jadhav and his team were active to do this little one cottage. And at till this stage also, everybody was not, confident that, but they say, okay, as a sample, we'll do it like this. But then again, we added the ribs, if you look at that here, and the structure started looking really interesting. And we could show them how the ventilation would happen, how the view would open up. And of course, with then they realized, and we started having the various different forms and formats being organized in a way. Some of them are up, some of them are ground plus one, and formulated. But our idea of having ventilation chimneys, light chimneys, were all there intact. Even we could extend out some of the viewing windows, so the rain would not get in, but air, light, ventilation would move in. And this is the beauty of ferrocrete, that you can take such a beautiful sculpturous form and you can go on doing it if one has a will to do, an interest to do it. Especially among the fast construction processes we are used to now in urbanization. Even in the villages, people have started adopting concrete, but purely RCC doesn't really work. Sometimes these kind of structures, especially in the rural areas, can actually help. And in few months we could see that the green started growing around, and we could finish them well with the acrylic based paint. And this is the beauty of a ferrocrete. We had one scientist who came, I don't know, we all are aware about it, but we actually, as in human body, we have bioelectricity, and they need to be earthed up. We don't do earthing, like as probably all our electrical connections have earthing, which is most important. So the one scientist came and walked around this place, and he measured the earthing. I mean, if you walk barefoot here, your body gets neutralized. See, we are unconsciously charging our body, overcharging our body through the lot of electronic gadgets around. And he showed that these cottages are meant to really gain the neutralization of our electrical charging, and it will really help. So people do feel very healthy when they walk barefoot within these cottages. And this is the beauty of these kind of technology to adopt, for the architectural solutions. And see, you're not only seeing the main structure, then you start seeing the steps into the ferrocrete, you create a retaining wall around that, and because to hold the structure together, you create a curves, and they start ending up being more sculpturesque. And if you look at from the top, when you put the earth over the ferrocrete, see, they start covering them up, and the people sitting up, or the cottages, they see the beautiful garden down and not the terraces with the dust. And this is something which turned out to be very interesting. And of course, the greenery also added a lot of insulation. So these cottages remain cool during summer and warm during winters.
Namaskar. We all are happy to be back on stage, and I would really thank
I'm not speaking of this. Okay.
the Society of Indo-American Art, and especially thanks to Shri Haridayal ji for bringing up this concert for us and for you. I believe this is a tough time for everybody, but I think music is the best stress burst for everyone, for you and for us. So, again, thanks to SIA, Haridayal ji. Today we are planning to play classical and semi-classical Bansuri concerts. And sharing stage with me today is a young talented Pakhawaj player, Ganesh Savanji, and on tabla, one and only one, Ojas Adia.
So probably this is
So I'll
got mixed
begin.
up with the, but we'll reduce the sound now. Fine. So anyway, this is what we ended up, having. So I would like to end up this presentation by saying that the various technologies exist all around, but they're all meant to serve architecture. Is how we as architects pick up the technology based on what is actually required. And there are always technology exist based on what solutions you are looking for. We architects need to actually look at those technologies as available resources to really fit to what kind of spaces we need to create, what kind of environments to generate. And lastly, I'd like to thank everybody to be here, and I truly appreciate your patience, people sitting here in the hall and wherever they all are on virtual platform. Thank you very much.
Thank you, sir. That was his presentations are always like a poetry. We thoroughly enjoy it, everyone. Please raise your hand for questions to Manish, sir. Volunteers will come with the mic to you. Online participants, please put your questions in the chat box.
Hello, sir.
Can you please stand up? Who's asking the question? Okay.
Yeah.
Sir, my main question was, how do you get an idea to build a spiritual center like this?
Can you repeat? I couldn't hear.
How do you get an idea to build a spiritual center so beautiful like this?
Oh, that's what, one has to study well, okay? And I was a good student probably. See, as I mentioned, if you go to a doctor, doctor has to diagnose, okay, what is the issue, what are the problems, okay. We as architects need to also have our own diagnosis. But we don't only do biological, survey, we do aesthetical survey. We also have to have a better experiences to give. And as architects, we are all supposed to get trained to provide solutions not only to meet functionality. That's a very base level. Hardly 10% I would give. It's very easy to fit a bedroom, bathroom, kitchen, or whatever you need to do. But how do you bring an environment for people to be healthy is something which matters a lot. The ideas is like, good music, okay, and good sound. The people who compositions who create a better music, okay. So there are ragas you have to learn about. And then you can have words. See, we hear a lot of songs, okay. Right? You have good songs, good lyrics, but if you put them in a good ragas, I have been listening or seeing people singing songs which might have been created 50 years back. And they have beautiful lyrics, but at the same time, very rhythmic sound musics. And this is what I think as architects we are supposed to provide. We have to see that the functionality of lyrics are well set within the ragas which are available. And if you look at in nature, All ragas do exist. It's just that we have to learn how to capture them. Okay?
Okay, another question from the chat window. Sir, can you read that question? The design of Sukhvihar.
Okay.
Shall I read it for you?
Huh.
The design of Sukhvihar cottages in Ferrocement is impressive and inspiring for us. I want to know how comfortable it feels inside, especially about temperature. How does Ferrocement help in keeping the thermal comfort levels better inside these houses?
See, first of all, ferrocement or ferrocrete has its own constraints of having a very thin layer. So it cannot give you insulation. For instance, we have a very thin skin. We need to wear some clothes in case if the temperature is quite cold outside. Or if it is hot, what do? We need to add layers. So ferrocrete is not responsible to give you a solution. It is the another layer probably you may require. For instance, I had asked Arjun to think about that, and he said they have added another layer of ferrocrete, which is so interesting. And then in between you create a air pocket, and air is a good thermal insulation. And also if you allow air to pass through, probably it will retain. In our case, we did a ground cover on top of it with a soil of almost about 1 feet thick, with a kind of a vegetation, which added another layer, and it keeps, the spaces and cool underneath. And your question also says that how one feel it inside. I mean, it's a very beautiful space inside because you don't see any corners. You get a good light. You got a surfaces which are more organic, somehow more resonates with our own body. See, our human body is designed by God with the no corners. It's much more, lucid and beautiful. And we have been trained to see the straight lines and the surfaces because they're easy to construct. But it's nice to experience those spaces if you can manage to live in those kind of surfaces. It's a very artistically, formulated spaces, and worth seeing, not only seeing but worth, experiencing them. One must go there and probably try to live there. Any other question? This gentleman there, called Yash.
Hello. So that's a fabulous structure. We all are inspired by the structure. I just wanted to ask have you carried out the rainwater harvesting for the entire project, because it's such a complex structure and there are a lot of vegetation that has been grown all together on the entire Sukhvihar, and there obviously must have been a lot of pipes that have been underneath and all of that. So can you throw some light over the rainwater structure that has been carried out?
Yes. See, as architects, I mean, we see the buildings which are visibly, quite revealed, when you see them. But many other services go underneath, especially under the ground, hidden somewhere. For instance, the electrical works, air conditioning works, ventilation works, plumbing work, drainage work. Even the sound systems, there's a lot of services being run. But when rainwater harvesting is something which is very, very important, and this particular project had a hill, so the rainwater would gush down through the hills. The biggest problem for the structural consultant was to see that the hill should not start coming down with the weight of the structure. So we had to anchor each and every guha of ferrocrete right into the ground. That's why the foundation they give, and we had to put some piles to ensure that the foundation is well retained. Now, the rainwater is very tricky. So we had to put a channelized pipes where we had to put perforated pipes with the geological fabric around so that the water would seep in and run down through the pipe all the way towards the existing nala, and we actually held the nala by creating a dam to ensure that the water retains there. And we use that as a feature of a landscape, but at the same time we can reuse the water. We also recharge the ground so that the water does not simply run down all the way to the lake, but keeps on recharging the ground. That's why you can see a lot of greenery, and now it is even much more healthier. So retaining water is a science by itself, and I must tell that all architects, designers must learn that how do we channelize the rainwater, recharge the grounds, retain the water, and ensuring that there is a channel to let the rainwater run down would not obstruct your building or somehow wash down our buildings. You must have seen in Uttaranchal, nowadays you get a bahad aati hai and the structure just simply run down. What is that? Because they are not designed to retain the structure anchored with the ground, allowing rainwater to rush down. And the hills can just simply slide down if you don't hold them properly. Vegetation also helps you to hold the ground together, allowing water channels to be generated. So trees are very, very important, and that is something which we all need to really inculcate as a knowledge while thinking only of a buildings and forms. The nature is equally important around. Anything else?
Yesterday in the technical session, we had a lot of questions. Patil sir, would you like to ask any question? We have practicing architects with us. Thank you. Okay, I hand over now to Kalyan Sundaram sir to invite our next speaker, please.
Thank you very much. I thank Manish ji very much. Please give him another big round of applause. I'm going to take off from where he's left off. Basically, he said that water should not be washed out and just wash the buildings down. They should be always harvested. Am I right, sir? I want all architects here to take this message that whenever you make a drawing, kindly place a note, even if the builder doesn't want to, that water should be harvested on your drawing. Can you give me a pledge, something like that? All young architects? Yes or no? Yes, thank you so much. With this, I would like to invite on stage the Waterman of India, should I call? I think someday very soon. Ullas Paranjpe sir, I'm very privileged to invite him on stage. He's been a proponent of rainwater harvesting for maybe 40 years, I don't know how long. That's the way I would like to introduce him. Ullas Paranjpe is a civil engineer from Sardar Patel University now. In Mumbai in 1971, he's worked for about 40 years. He worked for 10 years in the college as a lecturer. Later, he has started a NGO called as Jalavardhini Pratishthan, which is building water tanks in all villages, and they have built plenty of water tanks. He is going to talk about water conservation and how you can build water tanks. So, I invite him on stage. Yes. I'll just announce one more thing. Yeah, there is one thing. Yeah. Yes,
Just
please.
one announcement. After Paranjpe sir's session, we will be breaking out for parallel technical presentations in room number 404 and 406. So the presenters kindly be ready. Those who are presenting in the technical sessions followed by Paranjpe sir's session.
There is one thing which I want to mention. There are a lot of softwares. I think all architects should talk to mechanical engineers and to thermal engineers. The problems which are mentioned by both the architects, or rather the forms and the shapes, there is a software called as MathCAD which can give all these forms in very great accuracy. There are also softwares for thermal analysis, etc., in which you can calculate the insulations, and they can be very easy. What appears difficult for one person appears easy to another. So with this, I'd like to invite Ullas ji on stage for his session on water conservation and on how to build water tanks at home. Over to Ullas ji.
Good morning, everybody. Today the subject is
architect, water and ferrocement technology. So all projects, whether it is residential, commercial, industrial, needs water every day during construction. Without that, you cannot have good structure or bad structure. And even after construction is completed, you need water every day. So if an architect plans to have some space for the water, how he can do it, I'll show you the examples. Secondly, everybody must remember rainwater is a source of all water, whether it is a tap water, well water, borewell water or any other water. So rainwater management one has to look after when he is planning any residential, commercial or any project for that matter. And another thing is rainwater is a purest form of water. Nowadays, you know, well water is, borewell water is also polluted and all rivers also are polluted. So only choice remains for you to store the rainwater which is in a purest form, and it has a huge potential that I will show you. Rainwater has a huge potential and space to store is necessary in a drawing itself, because what happens as a water management consultant, our entry comes at a later date, and when at a later date when we find out the architect's ego gets hurt, sorry to say this one, because no space is kept to store the rainwater or water for that matter. So if it is planned on a day one itself, why? Because from 2001 and 2002, all the states have made it mandatory or compulsory for this rainwater harvesting. And ferrocement is obviously a very cost-effective technology to store the water. Which one? अच्छा ये उठ रही है ना? See, great, as per Kautilya Arthashastra, long back he has said what is Adhi Jala Magasthala. So when you are planning any building or anything on a plot, first you have to assess how much water is available. How much water is available means what? Water available from rainwater, then water, groundwater availability, and nearby source if a river, pond or anything is there. So you must first assess the availability of the water on that plot during the entire year, and accordingly if you plan your construction, then on no day you will have to run out for the water, or you will have to buy this 20-liter bottle from outside. So this is a primary thing which this Kautilya has said long back, thousands years back he has said it. So we must listen to this one and do it. How it can be done, that I will show you the practical examples. All forts constructed by Shivaji Maharaj, Chhatrapati Shivaji Maharaj, had an arrangement to store entire year's water. And we follow him. So naturally we must have a space for that. We must keep a space in a drawing itself. Then only a consultant will give the design, and then of course then plumbing, everything will be done according to that one. Water supply is a state subject. Before 40 years this was not required, because I have passed in 1971, and since then I am in a construction business. So up to say 1990, this rainwater harvesting was not that much, very much required. But after that, as the urbanization has increased a lot, we need this to be included in our design and drawing. State has a primary responsibility to provide the water, but then it is, they found it difficult. So they made it a mandatory to have this rainwater harvesting around 2001. So how do you find out this quantity of rainwater, that is the plot area into annual average rainfall? Say if you are staying in Pune, Pune has 750 millimeter rainfall. So 1 acre means 4,000 square meter will have 30 lakh liters of water. Every 1,000 square meter plot in Pune will have 7 lakh liters of water. And what we are planning for that one? No engineer or no architect is planning for that 7,50,000 liters of water per 1,000 square meter of a plot in Pune. In our Konkan region, it is a huge water available. So we must plan for this rainwater potential, that is area of a plot into annual average rainfall of that particular area. So similar to our floor space index, because all architect, all builder, or everybody understands FSI. So similar to that, we have developed this rainwater utilization index. Say if your plot is 1,000 square meter, you receive 7,50,000 liters of water. And if you are not using any water out of that as a first source of water, then your rainwater utilization index will be 0. So we have requested these municipal corporations and other to have at least 10%, 10 to 20% rainwater can be definitely stored and used. That example I will show you. So this is a one example where I am a member of Indian Water Works Association. We have our office at Santa Cruz. Our plot area is 340 square meter. And in Mumbai, annual average rainfall is 2 meter. So what is the quantity? 340 into 2, that is 680 cubic meter. Means on 340 square meter, we have 6,80,000 liters of water is available. So what we are doing, we are collecting some water and using it over there. So like that, if the arrangement to store the water is made, you can be definitely independent of any other source of water. And that way some plots are being developed. I will show you. This is a classic example. Everybody goes for a picnic and all that to this Pachgani and Mahabaleshwar. So it is just 2 kilometers before Pachgani bus stop. This MRA Institute is there. This is the educational institute. It started in 1973. And on a day one, they had an arrangement to store 10 lakh liters of water. So even if you go today, you will get the water which is stored in last monsoon, and they will give offer water to drink that water, and for all other things. See, and where it is stored in a plinth itself. Say this hall is there. This is a hall is of 500 square feet. And below this also, whatever rain falls on this hall will be stored in a plinth, because for plinth we have to go 6 feet below ground, and plinth is about 2 feet. So there we have 2 meter depth available to construct a tank. So this tank is constructed in a plinth itself, and this is a manhole. This is a manhole. In the hall itself, they have constructed a tank below. And it is very interesting. So all architects should go there at Pachgani and have a tour one day. You can come back from Pune in a one day. This is one example, and it's still working since 1973. This is another Hedgewar Rugnalaya at Aurangabad. See, below this garden, they have a tank of 11 lakh liters. See, even a hospital is storing 11 lakh liters of water. So whatever rooftop rainwater is there, you can definitely store it in a building itself. You don't need any space, because architect and everybody says, where is the space? There is no space for car parking and all that. Many things come, but that doesn't arise. This is second example. We visited this 2 months back. I have visited this place several times. This is a place at Mulshi. You can go and visit it. Meenakshi Pawar's bungalow, farmhouse is there. And see, this is a hall. This hall is there. And in hall, this, you see the flower pot. And below flower pot, the tank is there. She is storing 50,000 liters of water below hall itself. Can you imagine this? So, but you must see these things, and then we will come to know how to design it and how to implement it. One must see to believe it. At Mulshi you can go, and at Pachgani you can go. This is a tribal in our Karjat Taluka. We were constructing 10,000 liter tank at his farmhouse, and whenever I go to the site, whether it is a tribal or a millionaire, I tell him that you must store the rainwater. So I started telling him कि भाई आप क्यों नहीं अभी घर बनाते हो तब एक टाकी नीचे बना दो ना प्लिंथ में ही. So he said, साहब मेरे घर में आ जाओ. और उसने बताया, in a kitchen, see in a kitchen, below that he has a 10,000 liter tank. So even a tribal is doing these things without any reference to any architect or without reference to any structural consultant. Another thing I will show you, we went to Vadarwari in a Bid district. At Vadar, because we are doing social work, so when we go to a village, Bid district, they said कि भाई वहाँ महिला बचत गट है, उनको आप जरा थोड़े पानी के बारे में बता देना. तो हम वहाँ गए, तो बाद में चाय पीने के लिए एक वडार के घर में गए. So there we saw, this was the manhole. Some portion of a room was coming up. So I thought below that it must be a tank. So he said, in a Bid we get water once in a week, and every day we go far out. So we store that 10,000 liter. He had no idea of collecting rooftop rainwater. We said him, if you collect rooftop rainwater, at least during monsoon, you may not have to buy this once in a week water. So see, even a smallest person, means a poorest and smallest person who has no any engineering or any background, is having a capacity to store water in his apartment, building or anywhere. So I think it is everybody should do it. And this is for large scale cities. We have initiated, say for example, in Mumbai, Bombay IIT is having 500 acres of land. And 500 acre means 5,000 crore liters of water every year. So if you store 10% of that, how much it will be sufficient? It will be sufficient for 12,000 people in IIT Bombay. This is all in square kilometer area is written. And if you store 10%, annual average rainfall is written. This is 10%. One can definitely store rainwater on this plot. And if 5% is reused, then for IIT Bombay, they can provide water for 12,000 students. If they store 20%, then it is sufficient for 25,000 students. Same is the case of BARC. BARC is having 1,000 acre of a land. That means 1,000 crore liters of water. And 1,000 crore liter means what? Daily 2 or 3 crore liters of water. Then why they should buy water from this thing? Because these two institutes have lot many engineers available with them. They have a capacity to design themselves also. So they should set an example for others. And for large city, I went to Indore to give a lecture. Indore has an area of 141.1 square kilometer. There I said that annual average rainfall is 734 millimeter. If Indore stores 10% rainwater and 50% of that as a reuse, then it is sufficient for 3 lakh. For 20% it is 6 lakh. Like this, Aurangabad, all I have this. Like this you can calculate for your own areas, and see how much water you can definitely, and you must have a space to store 10% minimum potential of that land. And in MMR region in Mumbai has a huge potential. MMR region can support 4 crore population. And as on today, the population is not 4 crore of MMR region in Mumbai. So rainwater has a huge potential, and you must store it and use it as a first source of water. No tap water, no well water, no bore well water, or no canal water. Rainwater is more than sufficient for all your needs. And this ferrocement technology is very much cost effective. We have constructed more than 400-500 tanks, and we have taught this to many NGOs also. And those NGOs also have constructed in hundreds, 2,000. Even Reliance Foundation, this Sunil Srivastav is there, they are constructed more than 1,000 tanks. And it is just possible to store this tank cost effectively. Method in a ferrocement. Of course, in a building, how it is to be stored, there are many consultants, including our Milind Kulkarni is also there. They will give you the design and drawing how to construct within urban areas, because there you need the stability certificate and so many other things. So I don't waste much time, because many have shown this. This is a ferrocement technology, and you are going to have today itself some practical things also on ferrocement. See, we have one ferrocement museum at our Karjat. If you get some time, there a tank can be ferrocement technology, can be constructed in a different methods. We have the models over there. You are welcome to our Karjat museum. See, this is a workshop for IAS student, architectural student in Bandra, because whenever we go for a workshop, the management says we don't have a space or we don't have a time. There we conducted workshop for entire 1 week, and they don't have a space. So the students are working, you will find they are working on a terrace. So if you have a will to do it, you can do it. नहीं तो मैनेजमेंट में बोलते हैं कि पैसा नहीं है हमारे पास, जगह नहीं है, टाइम नहीं है, टाइट शेड्यूल टाइट है हमारा कॉलेज का. मैं बोला भाई साइट ऐसे कैसे हो सकता है. दिस इज ऑल्सो एजुकेशन. सो that is why I am showing you. The student had designed these potters and they constructed it. Here we use these natural fibers in place of chicken meat. That I will tell you some other time. This ferrocement can be used for water schemes also. Our Kulkarni Sahib is inaugurating this one at our tribal area, Mksss in near Danu. This is 25,000, this is 50,000 liter tank. This is 250,000 liter tank constructed. Even arch bandhara also you can construct in a ferrocement. From our experience and above example, because I have shown you the example, it is not theoretical. It is easily possible to store 10 to 20% of a rainwater potential and use it as a first source of water. You have to remember, you have to use rainwater as a first source of water. In many cases, one can be independent of any other source of water, and that is also possible. Here I had gone in Ferguson College, is having 65 acres of land. I told them you have 32 crore liters of water, but nothing went ahead. Let us see. We must go on trying ourselves. I don't know what is your campus area. Now you can calculate, and this management can definitely take the interest. Okay, thank you. You can ask the questions, otherwise we'll stop it over here.
Thank you very much, Ullas ji. We would like to have another big round of applause for him, please. I hope very soon he gets the Padma Awards. Okay. By the way, any questions, please? Yes. Yes. We'll take your questions. Can the volunteers give a mic? Yes, madam. And then we'll take Milind sir's question. Yes, sir. Madam, you can ask.
मला ऐकू कमी येतं प्रॉब्लेम
Namaste, sir.
हां
I agree with what you're saying. Rainwater harvesting is very important. My father was a civil engineer. He's no more now. But he also did rainwater harvesting on the roof of the house. And he saw to it the channels, the water came down into the well, which had been dug. So, you know, water was collected. Rainwater was collected in that way. He tried not to lose too much of water. But when the water is kept under a building, like a tank is built under the, like a hall, above is the hall. They say that if you have a water tank below the house or below the structure, it's bad luck. One should never have something
your
like
own
that.
thinking. Nothing is bad, madam.
If
There
they
are
say it is
examples
bad
and
luck,
people
many
are
people
using
have,
it.
no, they say it's bad luck, no Lakshmi enters the house if there is a water supply right in the hall or, you know, things like that. So
I
I
don't
just
think
wonder,
this
has it ever happened?
MRA Institute is there since 1973 and
Sir,
all
it's
IS officers and even municipal engineers go there for training.
Sir,
See,
they
it
go
is
for
all,
training,
it
it's
is all
not
our
residential.
mindset.
It's not residential.
Nothing is bad. I'll tell you, in the south, Amavasya is considered. In the south, Amavasya is considered as a good day, whereas in Maharashtra we say Amavasya को कुछ करना नहीं. अभी इसको क्या बोलेंगे? साउथ खत्म नहीं हो गया. साउथ आज भी वैसे ही है. करेंगे.
Thank you, sir.
ऐसा कोई दे नहीं है. We must use water as a first source of water. God has given us ample. So much water is there that we should export the water.
Not only that, दक्षिणेकडे बघून बसून नका असं म्हणतात, पण there it is many places it is considered auspicious to face the south and eat food. Actually, let me just point this out. So it's a matter of I totally agree. We'll just go to Milind sir's question.
I will not ask any questions, but I will speak of just four lines on Ullas Paransbe sir. I have known him for a very long time, and he is a pioneer. He is a passionate man, and is a one-man army who is working across the entire of Maharashtra with one passion. He doesn't have a car, he doesn't have a driver. He will be going by bus today afternoon at 3:30 back to his home. And believe me, I also travel a lot, and he has no commercial interest except one passion, that water for all. And that is the greatest beauty of that man. And Jalavardhani charges 1 rupee per liter of water for the training, for the services, and there are institutions which are giving him chicken mesh, weld mesh and sand and cement, and almost 400 to 500 tanks in absolute rural areas where even the buses don't go. He has moved there. Is a phenomena. Please give him a really big hand.
जाए न जाए बैलगाड़ी वहाँ जाए मारवाड़ी बोलता है, लेकिन उसके पहले उल्लास जी वहाँ पर जाके टैंक बांधेंगे. So I think any more questions we have, we will like to any other questions we can please network during the coming sessions or the lunch. I thank Ullas ji very much for his presentation. I thank all the speakers and the organizers. With this, of course, you are waiting for the technical sessions and for lunch, so I'd like to encourage all of you to kindly move to the next technical sessions. Okay, thank you very much. 404 and 403 for the technical sessions. Thank you.